Flushing is all about community, connecting the community, and that's just what the Flushing Riverview Trail Bridge does. The Riverview Trail is a 1.5-mile walking path that connects the west side of downtown Flushing, Michigan with the county park. The bridge is an integral part of the trail, allowing walkers to cross the Flint River safely and to enjoy nature on the way.
Its location has caused people to call it the bridge behind Beakies.
The 400-foot boardwalk that goes over the bridge elevates one above the Flint River and serves as a welcome mat to your experience. The bridge itself is composed primarily of 2x6 pressure-treated deck boards with square tubular steel sides and concrete pillars. The bridge is especially busy during Flushing's Trail of Terror. Every Halloween, this haunted adventure brings hundreds of people to the bridge. Although walkers traverse the bridge daily, the maximum capacity is during the Trail of Terror, when approximately 60 people are on the bridge at one time. This scenic bridge is composed of a variety of materials from the steel sides and supports to the wood decking and concrete pillars. We measured them all, but had to make several assumptions to complete the analysis. We assumed a uniform distribution of weight across the span of the bridge and simplified the cross-section. Calculations used average weights and publicly available data on construction materials. We utilized a simple free body diagram to represent just the middle portion of the bridge between the concrete pillars as a simply supported beam.
Identifying the materials, we researched their typical weights and converted them to the appropriate SI units. Pressure-treated deck boards have a weight of 4 kilograms per cubic meter, and square tube steel has a weight of 3.37 kilograms per linear meter for 1x1s and 9.68 kilograms per linear meter for 4x4s. Because a variety of people and pets use the bridge daily, we used the accepted average weight of a person, which is 62 kilograms. Aggregating the amounts of materials and people loading the bridge, we arrived at a total bearable weight for the bridge. This load was assumed to be distributed evenly across the bridge's length of 55.2 meters. For the analysis, we converted this to a point load and applied the statics equations of equilibrium. Starting with the sum of the forces in the x direction, which yields 0 newtons for force A sub x, summing the moments about point B gave us A sub y, and summing the forces in the y direction gave us B sub y, but the static analysis was insufficient. We had to find the shear force, V, and the moment, M, at any point along the span. So we made a cut at various points and found the shear force, and the bending moment at each cut. Next, we needed to define the cross-sectional area of the bridge deck in order to determine I, the second area moment of inertia, for our stress calculations. In this case, the axis runs parallel to the bridge deck length, so the height of the cross-section is cubed. We calculated the shear force and bending moment at various points on the bridge. There were 3 critical points on the bridge, near each end and at the center. The maximum normal stress was found at the center and shear at the edge. The maximum normal stress was found to be 8.1 megapascals, and the maximum shear stress was 0.02 megapascals. Normally accepted ultimate strength values for tensile and shear for the pressure-treated boards used in the bridge deck are 33 and 6 megapascals respectively. Comparing this to our stress results in a factor of safety of 4, making our bridge very safe. During our project, we analyzed the strength of the Riverview Trail Bridge in Flushing, Michigan, using both statics and solids concepts, including distributed and point loading. We calculated and plotted maximum normal and shear stresses in the cross-section at critical points along the bridge's span, and analyzed the bridge in comparison to accepted standards for its material. We calculated maximum stress at the center of the bridge's length and found this bridge to be very safe. In the end, this analysis was all about safety. But we couldn't finish this project without one last suppose. Suppose we decided to drive a school bus across the Riverview Trail Bridge. Sure, the bridge wasn't made for buses, but it would fit and makes for an interesting new extreme condition. A fully loaded bus weighs over 11,000 kilograms, including students. This increases the people load threefold, and the total bearable weight by almost 8,000 kilograms, making the maximum normal stress now 12.9 megapascals, and reducing the factor of safety to 2.6. The bridge is still safe, but this is not recommended. The Riverview Trail Bridge is one of the hidden treasures of Flushing. It was designed with the community in mind and has many benefits that add beauty to the Riverview Trail. The materials used blend in with its natural setting. The bridge is strong and safe, and now renovated will last for another 20 years through all kinds of weather and special events. The community can connect to both wildlife and nature through a simple walk across this bridge, from downtown to the park.